Hello, everyone. I welcome you all to dive into DevOps conference. So before we get started, let me introduce myself. My name is Yogesh Raheja. I am a CEO of Thinknyx Technologies. I have been helping many organizations in their journey in DevOps, infrastructure as code, containerization, and cloud computing. I have also authored several books on cloud and automation, such as Effective DevOps with AWS, Automation with Puppet, and Automation with Ansible, which have been published globally by Pact and Wiley Publishers. So without further delay, let's get started. So let's get started with our cloud native journey. So before we jump into container orchestration deeply, let us quickly understand how applications have been developed in past. So if we take ourselves a couple of years back, there was only one model in the market, which was known as one application per server. Because 15 years back, there was only one thing called data centers. So you used to have data centers, you used to have servers, and on top of those servers, your application development and application deployment work used to happen. But that was having a lot of limitations and challenges. Huge infrastructure cost, poor resource utilization, dedicated teams for everything, for your network, for your firewalls, for your operating system, for your data centers. So you used to have dedicated infrastructure teams. And the problem at that point in time was long downtimes. If anything happens to your machine, you used to have a long downtime because your applications will be down. So that was the reason your organization started looking into these challenges a lot. And then came the next level of IT, which is actually known as hypervisors or virtualization. So rather, I should not say that virtualization was new at that time, but I would say that there was a new era of virtualization, which was known as modern virtualization. So VMware 1998 jumped into it and they gave a feature to us stating, why are you purchasing servers again and again? Why can't you have pool of servers, install a software and create virtual hardwares? And this solution became popular in couple of years. So from 2005-6 onwards, virtualization started getting popularity in the IT, which gave us the flexibility to have multiple applications hosted on a pool of servers. So we used to have multiple servers like it's shown over here, right? And on top of that, we used to install one software. The categorization in that software is actually known as hypervisors. Now, these hypervisors will be provided by a lot of organizations. If it is provided by VMware, it is ESXi. If it is provided by Microsoft, it is Hyper-V. Or if it is provided by Linux, open source, it is KVM. Likewise, you have Zen also. So what these softwares will do, they will actually give you one flexibility where you will be having a pool of resources available. And what you used to do is you used to create virtual machines on top of them. And this gives the flexibility for you to actually scale or actually provision your machines with quicker time. So your deployment time as well as your provisioning time decreased. So this gave a lot of other flexibilities also. Now, when it comes to your hardware, if your hardware is down, or if you want to increase memory or CPU in your hardware, it was a long process. But when it comes to hypervisors, it is just a matter of few seconds or minutes. So you can increase the capacity on the fly, better resource utilization, downtime was decreased less. It became very less. Reason being, when it was hardware, the downtime was in hours. But when it comes to your virtual machines, it is in minutes now. So but there are still some challenges also associated with it. You still need to maintain servers. You still need to have data center. You still need to have dedicated teams. And again, there is huge infrastructure cost also. Now, just I'll let you know one more thing. When you talk about cloud, what is cloud? Cloud is also a type of virtualization. The only difference in cloud and your local virtualization is in your local virtualization, you should have data centers also. But when you talk about cloud, this data center part will be taken care by cloud. And you will be connecting to their data center and you will be using pay as you go. So you create virtual machines there. So virtual machine is is similar like this, but it is not hosted on your servers. It is hosted on cloud data center, right? So there are still a lot of challenges. I'll give you one simple example. If I ask you to take one VM or one server and install multiple operating systems on top of that, the answer will be no, that is not possible. Because if you have one server, there will be one operating system, right? Similarly, let's say I ask you to install multiple same type of applications on a same server. Obviously, it is possible, but there will be a lot of binary conflicts or challenges. Now, looking into that, a new term or terminologies came into the market, and that are actually known as containers. Now, what is container? When you talk about hypervisor, you can simply say that it's a virtualization on hardware. And when you talk about containers, it's actually a type of a virtualization on top of your operating system. Like you have hypervisors, a keyword, similarly you have something called CRI. CRI stands for Container Runtime Interface. Now, Container Runtime Interface means a term which will be used as a software to install your container creation softwares. Now, Docker, RKT, Cryo, Kata, they all are CRIs. So you can use any of these softwares which will help you to actually do a virtualization at operating system level. And when you have operating system virtualization, you probably can create multiple lightweight isolated environments on top of a same operating system. And that is nothing. That is actually known as your containers. Now, containers are giving a lot of flexibilities to us. One thing is they are immutable. We never log in inside a container and do the things. What we do is we just create them on the fly. If it is not working, remove and recreate it. So no manual interventions are required. They are very cost effective also. Now, when you build container, now you need something called container images. And what we do is we put everything inside that container image. You don't have to put dependency. You don't have to put prerequisites. You don't have to put anything out of the box. What you have to do is when you are creating your images, you need to bundle everything together. And once it is bundled, you can use it anywhere. That is the reason we always used to say containers use a slogan called build anywhere, run anywhere. You can build an image on your local laptop and you can run it like a container on AWS, on GCP, on Azure, on VMware, or anywhere where you have just one operating system, right? You don't need multiple teams to manage it. Containers are for everyone. If you are a developer, it's for you. If you are a tester, it's for you. If you are from operations team, it's for you. And on top of that, the downtime with using containers, only containers, is in seconds. So when you talk about downtime in hardware, it is in hours. When you talk downtime in virtual machines, it's in minutes. But when you talk about downtime in containers, right, it's in seconds. And when you take this layer to other layer, which is container orchestration, that seconds will become zero downtime. So your applications ideally will be running every time. And one of the best example is google.com. Google.com runs on containers and we hardly see Google is going down. Reason being, as soon as it comes down, the recovery will happen automatically because it runs in scalability mode, right? So at a very high level, so we were having data centers, then virtualization came, and now we are moving into something called containers. And containers will going to rule the world for next couple of years, right? And when you talk about containers, now we know containers is a lightweight operating system or lightweight isolated environment. The question comes, how can I create containers? To create containers, you need to use software. And when it comes to de facto, there is only one de facto in the market at this point in time, which is known as Docker. So now what we will do is we will quickly understand what is Docker. So when you talk about Docker, Docker is a platform to build, ship, and run containerized applications. So when we talk about build, actually we are talking about something called Docker file. So Docker gave us one flexibility to create one text file, put some instructions, right, and bundle these instructions into a binary. And that binary is actually known as your image. So to run a container, what minimum thing you need is that is known as image. So Docker provides us the flexibility to build that image. Once the image is built, what we do is we share that image. Sharing of an image is actually known as shipping of an image. And when you talk about ship, you always talk about a new technology which is known as registry. Like you have GitHub, GitLab, right, or Bitbucket. They are source code repositories. Similarly, when you talk about sharing your images, you need to use something called registry. So by default, if you talk in the public terms, you have something called Docker Hub. Docker Hub is a public registry where you can share the image and you can take the images. Apart from that, there are a lot of other open source private registry options also available. Like you have Harbor, you have Quay. From cloud offerings, you have ECR, which is Elastic Container Registry. You have ACR, which is Azure Container Registry. You have GCR, which is Google Container Registry. Nexus is providing their container registry solution. JFrog is providing their container registry solution. When you talk about enterprise organizations, right, you need to use private registries. When you talk about testing and learning, you can use something called Docker Hub. Even Docker Hub provides something called private registry, but you have to pay for that, right? So what you do is you build your image, you ship your image. Once image is shipped, now anyone in your organization can take that image and create container out of it. Now you can think container is nothing. Container is a running instance of your image. If you ask me what is image, image is a read-only template. If you ask me what is container, container is a read-write template. So you can write in container. You cannot write in image because image is a static thing. Right? So we build image, we ship image, and we run containers out of it. And if our containers are running, it means our applications are running. And that is the reason we always say Docker is a platform. It is just not only helping us to create containers, it is helping us to build the images, ship the images, and run the containers. And that is the reason the definition of Docker says it's a platform to build, ship, and run your containerized applications. Right? Next thing is the architecture of a Docker. Now, when you talk about Docker architecture, again, always remember when people say Docker, they are actually talking about Docker engine. There are a lot of other products of Docker also, like Docker Swarm, Kitematics, Docker Cloud, Docker Data Center. But when people are just saying Docker, they are actually talking about Docker engine. Docker engine is a core part of entire Docker ecosystem. And what we will do is we will understand the architecture of Docker first. Now, in a simple layman language, I can say Docker is a master client-based technology. But when you talk about how actually that works, right? So what you have to consider is you need to consider this entire architecture. Right? So there are two primary components. One is CLI and one is your Docker daemon or Docker server. Now this component is server. This server where you install Docker is actually known as Docker host. As soon as you install Docker engine, you will be having two components. One is known as Docker client, this thing, and one is known as Docker daemon. Docker daemon is nothing. This is server, Docker server, you can say. And Docker client is nothing. It is your Docker CLI utility. So via CLI utility, we interact with your Docker host, right? So this is your client. With client, we interact with server. When you interact with server, we are actually interacting with Docker daemon, right? So now Docker daemon, initially in 2013 when Docker came, it was a very rigid monolithic binary. But over the period of time, right, in from 2013 till 2021, this Docker have been changed drastically. A lot of components have been breaked from Docker daemon and they are independent binaries now, like containerd, runc, right? And even there is something called libcontainer, which is actually interacting with namespaces, C groups, and Linux kernel. So what actually happens? As soon as a user, I will execute a command. Example, I am executing something called Docker container run -idd -name Yogesh space image name, let's say Ubuntu 18.04. As soon as I enter that, what will happen is that command will going to get converted into a REST API. That REST API will going to hit your Docker daemon. Now Docker daemon will do all of the heavy lifting for you. Example, if I need to create volumes or volumes are associated with it, or which network I need to use, either images are available or not, all those heavy lifting will be taken care by Docker daemon. Once done, it will pass the control to your containerd. Now, what containerd will do? Containerd is responsible for all container operations, right? Whenever you want any container operations, that will be taken care by containerd. Creation of a container, stop of a container, start of a container, right? All such things will be taken care by your containerd. Actually, containerd will make your container daemon less also. There was one problem when containerd was not there. Whenever your container used to get down, whenever your Docker daemon used to get down, your container were becoming unreachable. This problem got solved when containerd was introduced. Now, when your Docker daemon is down, your containerd is up. And containerd will take care of your all running containers in the absence of Docker daemon itself. So containerd provides something called daemon-less containers. This was a very good value add in the architecture. Then the things used to get passed to your run C. Run C means run a container. So your container D will create a bundle, and that bundle will going to get passed to your run C. Run C means create a container or run a container. Now run C under the hood will going to talk to a binary of Docker, which is known as lib container. Now lib container was a replacement of LXC. Lib container is responsible for actually interacting with your namespaces and C groups. Now, these are the things which have been provided to Linux kernel by Google in 2008. Right? These are the capabilities of Linux which helps us to create containers. Right? And then with the help of Linux container, an isolated environment will going to get created. And this isolated environment is actually known as containers. Under the hood, these all things are actually taking place. But at a user level, we just execute one command. So every command you are executing on Docker is actually going through this process. So as soon as you execute a command, Docker daemon, from Docker daemon, container D, from container D, run C. From run C, it will go to lib container. From lib container, namespaces, C groups will play their part. And then with the help of Linux container, one isolated environment, one lightweight isolated environment will going to get created. And this environment is actually known as containers. Right? Now, I'll tell you one more thing. In December 2020, there was one announcement which happened that Kubernetes will going to depreciate the usage of Docker from 1.23 version of Kubernetes. And people were scared. What will going to happen? Now we are not going to use Docker. Now, what Kubernetes is saying, I just need a container creation software. I don't need all of these software because it is making my things very bulky. Now, what that mean is now from 1.23 version of Kubernetes, you are not going to use entire Docker software. But what Kubernetes is saying, you can use this particular thing called container D. Now, container D will be treated as a runtime environment because in Kubernetes, you just need a software to create containers. You don't need building of images. You don't need shipping of images. And why should we have rest of the things installed on Kubernetes environment? Right? So when someone says we are deprecating Docker, that doesn't mean that you are deprecating entire Docker. That means you are going to use only this portion, this component of Docker, which is known as container D. Now, container D is actually given to a community by Docker. So it's a free library available. So anyone can use it. Even you can use it and you can create your own CRI also. So now when 1.23 version of Kubernetes will going to get released, you will not going to use you to install entire Docker. You are just going to install this lightweight binary called container D. So I just want to clarify this because we are into deep dive into DevOps. So better I can tell you all those nitty gritties which are actually there in the market. Now this is the architecture. Let's move forward. Now when you talk about Docker, you just need to have one thing under your belt, and that is known as how to create your images. When you talk about creation of images, what you have to do is you just need to understand something called Docker file. Now, actually, there are two methods to create images. One is commit method, one is build method. Now, build method is known as Docker file method. Docker commit method is the old method where we used to create, single fat layer. Now, here we will not create single fat layer. We are going to create multiple lightweight layers. Right? So, Docker file is a plain text file. You don't need to have, extension like YAML or Python or Ruby. No, it's a simple plain text file. Right? What it contains two things. One is your keywords. Anything which you see in uppercase, these all are Docker defined keywords. You cannot change them. You have to use them. Right? And whatever you see here as commands, these all are user defined arguments. Now, when you create a Docker file, you actually want to automate your image builds. Like in past, we used to do package builds. Now in container or cloud native terminologies, what we are doing is we are actually creating Docker files. We are automating our image builds. Now, it means your Docker file should be non-interactive. That is the reason you see I have kept everywhere as -y. So it should be a silent installation, right? And whatever steps you need. Now, if you see here, this is my suitcase, right? I want to create a web server image. So what I'm doing, I want to use CentOS latest image. This is my base operating system. Then I am installing the prerequisites. Then I am installing my application. I am putting my code over here, which is a simple hello Docker. I'm telling that this application is run on port number 80, and then I'm starting my applications. Once this is done, what I will do is I convert it into one image. Once image is built, I can use it anywhere. Wherever I'm going to use it, it will going to create a same web server for me, right? So in Docker, you just need to understand how to create Docker files. And it will going to take some time because this will obviously need some of the experience for complex cloud native applications, right? One thing more, when you talk about these instructions, now you need not to go here and there and find it out. What you do is, let me give you the entire part. You just go to the Bible of Docker, which is known as docs.docker.com. Just go to this reference, click here, and you will be having something called Docker file reference. If you come to this Docker file reference, right, come to the right hand side section, and you are going to see these capital letters. See here, from, run, cmd, label, maintainer, expose, env, add, copy, entry point. These all are instructions. Now there are total 17 instructions as of now, right? And at a large scale, if I tell you, we hardly use 10, 12 instructions on daily basis. But if anything you think is missing and you want to explore that, just come to docs.docker.com, come to references, come to Docker file, and here you will be able to see all these instructions. Click any of these instructions, it will take you to the explanation of that. Just go through it, understand that, create your Docker file by referencing this. Now, this is very useful link, right? Let's come back. Now, this is all when it comes to your Docker. So when we talk about container orchestration, so container technology is a prerequisite to it. Unless and until you are not having images, you cannot start your container orchestration journey. People are saying we want to learn Kubernetes. But believe me, unless and until your Linux fundamentals are not clear and your container fundamentals, Docker at this point in time is not clear, it will be very difficult for you to actually kickstart your Kubernetes journey. Because Kubernetes is a management platform. It will not going to create images for you. And unless and until you are not having images, you are not having your applications. And unless and until you are not having your applications, what's the use of platform? So that is the reason cloud native is a journey. You need to understand Linux. You need to understand any of the CRI tool like Docker or RKT or Cryo, and then your container orchestration technologies like Kubernetes or Docker Swarm or Mesosphere, whatever, right? So now what we will do is we are going to understand orchestration. So this is actually going to be deep dive. Now we learned about containers and now we have our applications packaged into a Docker container. But what next? How do you run it in production? What if your application relies on other containers such as databases, messaging services, or backend services? What if number of users increases and you need to scale your application? Because Docker is for one system, not for multiple systems. How do you scale down when load decreases? Right? To enable all these functionalities, you need to understand a platform called container orchestration platform. So now a platform which provide you the flexibility for self-healing, scaling, scale up, scale down, right? Your load balancing and all other features. For that, you need to use something called container orchestration. And when you talk about container orchestration, the only name stands out at this point in time is Kubernetes. Now there are other container orchestration technologies available in the market. You have Docker Swarm, you have Apache Mesosphere. But when you talk about de facto, people always talk about a combination of Docker plus Kubernetes. Docker as a CRI, Kubernetes as a container orchestration. So when you talk about terms, it is container runtime interface, which is Docker, and container orchestration, which is Kubernetes. Now you might use different tools also, but as per market, this is the de facto at this point in time. Make sense? So now what we are going to do is we are going to understand the architecture of a Kubernetes. So when we talk about architecture of a Kubernetes, again, Kubernetes is based upon master client architecture. You need a dedicated master you need dedicated workers. So clients are also known as workers, minions, whatever you want to say. But at a minimum, you need one master and you need one worker node, right? So master consists of multiple components. So when you talk about the first component, it is actually your Kube API server component. Whenever you install Kubernetes master, it installs a lot of components under the hood. And all these components are actually added as containers or installed as containers or pods, right? So the first component is your Kube API server. This is a primary component which provide authentication, authorization, and is the only point of contact for any communication inside and outside cluster. So when you talk about interacting with Kubernetes master from outside, as a user, you are actually going to hit your Kube API server component. Similarly, if internally one component want to talk to another component, they are actually using the services of Kube API server component. If this component is down, you cannot interact with your Kubernetes master. It means your Kubernetes is down, right? Second is your etcd. When you talk about your etcd, etcd is a fully distributed data store for Kubernetes. It stores and manages the entire state of your Kubernetes cluster and its various objects like pod, replica sets, services, deployments, etc. So the prime responsibility of etcd is to store the desired state of your entire cluster. Whatever is running in your cluster, the entire configuration state of that will going to get stored in etcd. And this is the place via which Kubernetes provides self-healing capabilities. If anything happens to your container, which is running inside your Kubernetes environment, who will take the self-healing, responsibility? It is actually etcd, because etcd will going to check the configuration. If configuration is not getting matched, again Kubernetes ecosystem will going to self-heal the things for you. So that is the reason we always used to say we will be having desired state in etcd, right? So API server primary functionality is communication. etcd, this is your distributed data store, right? And next is your controller manager. Everything in Kubernetes is handled by various controller managers. Like in old technologies, we used to say plugins. Now we never say plugin in Kubernetes. We always say something called controller manager. Everything in Kubernetes is having a controller manager associated with it, right? But when you talk about installation, so out of various controller managers, node controller manager and replication controller manager are the major one, which get installed or enabled when we actually install our Kubernetes master. Right? There are three more which get enabled, but two of them, which is your node controller manager and replication controller manager, they are very, very important. Reason being, your node controller manager is responsible for identifying the potential node and help you in case of node failures. If anything happens to your server where your cloud native applications are running which are managed by Kubernetes, now how they will going to go somewhere else? Who is tracking the state? All these things will be taken care by your node controller manager. Similarly, let's say I want to scale out my application. I want my application to be highly available. In that case, I cannot take a risk of having a single point of failure by hosting multiple instances of my application on a same server. I want to distribute them so that in case of one server failure, I should have my applications running on other servers. All such capabilities will be provided by your replication controller manager. So replication controller manager is responsible for distributing your load on worker node for same application. Similarly, once everything is done, next part is your scheduler. Now the responsibility of a scheduler is to get your work scheduled on these worker nodes. Now we authenticated, desired state is here. We have identified the node, we identified the replication stuff. Now who the bundle is created, that bundle will go to scheduler. Scheduler is responsible to get it scheduled on a worker node. But scheduler cannot talk because it's not a communication component. What scheduler will do is it will go to your Kube API server. And from API server will going to make a connection with the kubelet of servers, right? And this kubelet is the prime component in your all Kubernetes ecosystem. So kubelet will be running in all servers, master as well as workers. This is responsible for your entire pod management. Then kubelet will actually interact with your Docker, which is your CRI, and then a container will going to get created. Once container will going to get created, after that Kubernetes will going to add some features on top of this container. It will add some other things on top of this container, like your networking capabilities, your DNS capabilities, right, and so on and so forth. And then this encapsulated layer on top of container is actually known as pod. And pod is something which we always consider when we talk about Kubernetes. And when you talk about kube proxy, now kube proxy is a networking component in your Kubernetes ecosystem. So it maintains network rules on nodes so that the containers or pods can talk to each other. So what happens under the hood is, as soon as I execute any imperative or YAML, what happens is I'm going to interact with your Kube API server. Then the things will going to get stored in your etcd. Then the node will going to get identified. Then the replication factor will going to get identified. Bundle will going to get passed to your scheduler. Scheduler will interact with API server and say, please make connection with the server. That connection will going to get made with the server with a component called kubelet. Kubelet will going to interact with your CRI, which is Docker. It can be anything which is supported by Docker, by Kubernetes. Then this CRI will going to create a container. On top of this container, some information will going to get added, like networking rules, which will be added by kubeproxy, DNS rules, naming conventions, etc. And then this will going to get wrapped. This wrapper is actually known as your pod. Now, pod is the smallest unit in Kubernetes. When we come to the objects, I'll tell you what this is. And in the practical session, I'm going to create all those things. So don't worry. But I just want to tell you how a single command is actually creating all those things. Now, when you talk about interacting with your Kubernetes master, there are two ways or three ways rather in which you can interact. One is your CLI, which is your kubectl or kubectl utility. You can have one open source tool called Kubernetes dashboard, via which you can interact with your Kubernetes master. Or in fact, you can have a third option, which is your APIs. You can directly hit the APIs of your Kubernetes master and you can interact with your Kubernetes ecosystem, right? So this is all about your architecture. Now, next part is features, or you can say why people are using Kubernetes. Now, there are lot of points which you can discuss of impressing anyone to use Kubernetes, right? I'll just touch base couple of them. The first one is self-healing. When you talk about Docker, Docker is just used to create container. Docker, if container comes down, it will not going to get recovered automatically. Who will provide self-healing capabilities? Kubernetes will provide self-healing capabilities to you, right? So as soon as your pod comes down, right, automatically Kubernetes will going to do a self-healing for you. You need not to log in into any server to do anything. It will be taken care by Kubernetes software for you. Next, your scaling. What if my application, cloud native applications are getting famous? I want to scale them out. You want to scale a container out, not a VM. If you want to scale out a container, your platform should be capable enough for that. And that is where your Kubernetes jump in. Now, there are two ways of doing a scaling: manual scaling or automatic scaling. Manual scaling with command line. And automatic scaling, for that, you need to use something called HPA, horizontal pod autoscaler. And for that, indeed, you have to use something called metric server also. But yes, capabilities are available. Now, next thing, why, because of which Kubernetes have become paramount in the industry, that is known as application upgrades. When you talk about application upgrade, till 2015-16, in my career of at that point in time 11-12 years, whenever it comes to application upgrades, we always used to worry that we don't know either application will going to get successfully upgraded or not. If not, rollback will going to be a challenge for us. But when Kubernetes came, this challenge become ease to resolve now. Now, how it is possible? It is possible because you can do something called rolling upgrades in Kubernetes. You can upgrade your applications on the fly without downtime. Now, again, I am saying on the fly without downtime. Kubernetes provide you the flexibility to upgrade your applications with zero downtime. This is a big statement. And this statement is actually making Kubernetes de facto. And because of this statement only, you are nowadays you see every minute, a lot of big organizations, enterprise organizations, they are doing rollouts in production. Why? Because they have Kubernetes. Your AWS, your Google, your Microsoft, Netflix, Facebook, they all are doing deployments every minute now. Why? Because they know if anything goes fail, Kubernetes will going to do a rollout within fraction of seconds for us. So application upgrade become very simple now. Apart from that, there are other features also. Example, lot of storage options Kubernetes support. You can use third-party SDS, software-defined storage like Portworx, Storage OS, Flocker, Scale.io. Similarly, when you talk about Kubernetes, Kubernetes provide you something called one-time execution or batch execution. When you talk about data analytics, right? You don't want to have servers or containers running for a greater duration. What you do is you actually create crons, right? So whenever a thing is coming, automatically a container will going to get executed. Your analytic framework will going to get run. It will going to put your things into a centralized storage, and then your container will going to get terminated. So you can do all such things using batch execution. You can use one-time job, or you can use recurring job. If you are using recurring job, you have to use cron jobs. If you are using one-time task, you can use something called jobs. Example, I have thousand of servers and I want to find out one information out of them. So what I'll do is I'll just do temporary execution using jobs. Let's say I want to email one report every Monday to my entire organization. What I will do is I'll do a cron job. All such options are provided with Kubernetes. Apart from that, there is one more thing which is very important. That is known as your confidential data management. When you talk about Kubernetes, it provides you two more things. One is for configuration, which is known as config maps. One is for your confidential data, which is known as secrets. We are going to see config maps and secrets in action, so don't worry. Last but not the least, you have something called load balancer and service discovery. When we talk about load balancer, people always think we are talking about physical load balancers. Actually, we are not talking about physical load balancers. We are talking about container level load balancer. Inside a server, I have multiple containers. I want to distribute a load on top of those containers. I cannot do that using outside load balancers. I have to have something called inbuilt, or I have to have something called inside container load balancers. And Docker doesn't provide that. For that, again, you have to rely upon Kubernetes. Kubernetes come up with out of the box solution called services. Now, services actually provide the load balancing capabilities also. So you don't have to set up anything at all. So L4 level of load balancing, network level load balancing will be provided by Kubernetes out of the box. Even Kubernetes provide you additional flexibility to install L7 external load balancers, but they are container load balancers, not VM load balancers. So you have Nginx, Contour, Istio. So they all provide something called L7 application layer container load balancing capabilities. But out of the box, Kubernetes comes with L4, which is your network load balancer. Apart from this, also there are a lot of other features. Features are endless. Actually, because of that, Kubernetes is sometimes, difficult also, or complicated also, because when new feature will come, new complexities will also come. But yes, Kubernetes is rich in features. Next is your objects. So when you talk about Kubernetes objects, now your journey will start with something called pod. So what is pod actually? When you talk about Kubernetes, we never talk about something called container, because container is for CRI. For orchestrator, you need to put some information on top of that container so that you can manage it across servers. And that capabilities are added in Kubernetes by a term called pod. So pod is nothing, it's the smallest unit in Kubernetes. Everything in Kubernetes is actually lying on this object called pod. So this is my container. On top of that container, I created something called pod. But pod will not going to provide you self-healing capabilities. Pod will not going to provide you scaling capabilities, and pod will not going to provide you application upgrade capabilities, because pod is just an encapsulated layer on top of container. Then what's the use of this? The use is we are just making it compatible with Kubernetes. But when it comes to production, we are not going to use pod. We are going to use something called replica set. Now, your all scaling capabilities and self-healing capabilities is actually provided by replica set. What we do is we don't create pod. We create an object on top of pod that is known as replica set. Replica set will automatically create a pod. Pod will automatically going to create your containers where your applications will be running. Now, what features replica set will provide? Replica set will provide you self-healing of pod, and replica set will provide you can have more than one pod inside it, so that you can have a HA, means scaling capabilities, right? But if you want to do application upgrade, again, you need to do a lot of manual stuff. You need to delete this replica set, recreate a replica set with a new image, and your new application will going to get run. Kubernetes says, why you want to do that? Let me take care of that. Don't create replica set. Create another object on top of it. And that object is actually known as deployment. When you talk about production, you will always see people are creating Kubernetes deployments. It means they are creating deployments which will automatically create the replica set, which will automatically create the pod and subsequent containers. Now, question comes, why deployment? Now, pod will be providing the container part, means encapsulation on top of container. Replica set is providing you scaling and HA, right? Or scaling or self-healing. Deployment is actually providing you something because of which Kubernetes is famous. That is known as zero downtime for your application upgrade. Your application level tasks will be taken care by this deployment. So you will hear these terms called rolling upgrades, rollouts, rollbacks in Kubernetes. Who is actually supporting that? This particular object called deployment is actually supporting that. And that is the reason we always create something called deployments in Kubernetes. Right? So pod, smallest unit, on top of that replica set, on top of that deployment. Now, when you talk about creation of these things, this can be done in two ways. One way is imperative using command line, and one way is your YAML files, right? So that is known as your manifests. Let me give you a sample file. I'm going to create it, so don't worry. I just want to show you how it looks like. So what we do is we create files like this. I can 100% customization can be done using YAML files. Otherwise, there is a command line utility also, kubectl, and you can do imperative way stuff. If you closely see here, now these are the four things you need to remember always in any of the object in Kubernetes: API version, kind, metadata, and spec. And now this API is your API version for your object. What you want to create? I want to create deployment. I want to create service. I want to create daemon set. I want to create config map. I want to create secrets. So based upon that, you will be having an appropriate APIs associated with it. I want to hit this API for this object. So kind is object, API is API of that object. Metadata is information about this object, whatever you are creating. And then under spec, the specifications of that object, what you want to do. In any of almost all of your Kubernetes objects, you need to define API version, kind, metadata, and spec. There are some special cases like your secrets and config map where you don't have spec, but you have something called data. But apart from that, everywhere you will be having these sections. And under these sections, you just need to write these stuff. And from where we can refer it. Now let me show that too. If I come to my Kubernetes Bible, which is kubernetes.io, if I go to documentation, under documentation, if you come to look up reference information, there is something called overview of API. Click here, and you will be having something called, see here, this API. Click here, and it will going to take you to the entire Kubernetes API tree, because in Kubernetes, everything is API, right? So if you see here, what I'm doing is I'm going to that particular page. These all are the objects. See here. These all are the objects. Example, I want to see things related to deployment. The file which I have just shown you. What I will do is I'll go to this deployment section here. See here. This is deployment. Click here And as soon as I go here, see this API version, kind, metadata, and spec. You don't have to give state because state will be created when you create your object. See this API version, kind, metadata, and spec. Now, referencing this, what I will do is I'm going to create this YAML file. Now, this is the best way of learning Kubernetes. People say we know Kubernetes, but when you ask how these files have been created, they don't know. Reason being, they just do copy paste. But I want everyone to actually refer this documentation to create. Perfect. So let me come back. I'm going to create these manifests and I'll show you some of the hidden tips, tips which will going to help you to create these YAML skeletons. Next is your services. Now, till now, whatever we have saw, we just created our things. How we can access these things. In order to access these things, you need to create something called services. Now, Kubernetes services enable communication between various components within a pod and outside of your cluster. So there are three types of services which are present out of the box. One is cluster IP. Now, let's say you have a cluster and you want internal communication, private communication. For that, you will be creating a service of type cluster IP. If you want people to actually access your containers or pods from outside, you can either create node port type of a service or load balancer type of a service. When you talk about node port type of a service, this is the service or this is the access which will be available from the port of the server. Similarly, when you talk about load balancer, now this load balancer capabilities or services are applicable only for cloud load balancers. If every service will going to create one virtual load balancer for you, and it will going to be very expensive service. That is the reason you will see people never use this. What they use is either they use node port or they use external L7 capabilities for load balancer, which is known as ingress in Kubernetes. Otherwise, by default, these are the three service types which will be available. Cluster IP for internal communication within the pods, node port and load balancers for external communication. If you are using on-premises and you don't have software load balancers, you will be using node port type of a service, which I am going to demonstrate. And if you are using AWS, GCP, or Azure, you can even use cloud load balancers, which are your virtual load balancers. But this is very expensive service. But in case you want your object-to-object communication happens internally or externally, you need to use something called Kubernetes services. So services is another object in Kubernetes. Again, next. So config map and secrets, like I told you, so we have pods, replica sets, deployments, services. Similarly, you have config maps and you have services, secrets, PV, PVC, and so on and so forth. So when you talk about config maps are nothing. These are configurations. Now what I did, I created my image. Image will be having some default configurations. Now I should have a way in Kubernetes to change that default configuration. Example, index.html file. In my Docker image, I gave ABC in my index.html file. But when I'm deploying it, I don't want to create a new image to change my index.html file. I want to do that on the fly. Who will help me in Kubernetes to do that? Your config maps will going to help you for that. So config maps are used to pass configurations to your Kubernetes ecosystem or Kubernetes objects, but they are open. There is no encoding which happened in config maps, right? So what we do is, if you want to pass some confidential data, example, you tagged your image in such a way it need username and password. I cannot give username and password open. It will be against my security compliance. How can I do that? For that, I am going to use something called secrets. Secrets is not encryption. Secret is encoding. It's just another layer of security. People sometimes get confused that secret provides encryption. This is wrong statement. Secret in Kubernetes won't provide you encryption. It just provides you encoding, base 64 encoding. So you can encode your username and password, which will not be getting appeared in the files or outputs, right? But you can decode it at any point in time if you have access to your Kubernetes. So potential data and then pass that encoded values to your pods or objects. Similarly, you have other objects also: persistent volume claim, daemon set, storage classes, network policies, ingress resources, ingress controller. There are a lot of objects. But pod, replica set, deployment, services, config map, and secrets, these are very, very essential. In fact, PVPVC is also very essential. If you know these 4, 5, 6 objects, probably you are in a position where you can understand rest all of the things yourself. Right? Perfect. Now, next thing. When you talk about Kubernetes, now Kubernetes is just an ecosystem where you can integrate a lot of stuff. But there is one challenge, and that challenge is Kubernetes doesn't come out of the box with monitoring, alerting, and dashboarding system. So what you have to do is you need to use third-party solutions for monitoring your Kubernetes or cloud native state, and then make it easy for other users to get those things on dashboard. For that, what industry is using, they are using two very famous tools. One is Prometheus and one is Grafana. So when you talk about Prometheus is an open source system tool for monitoring and alerting systems. It is actually created by a company called SoundCloud in 2012, and they gave it to the community. And believe me, after Kubernetes, Prometheus was the second project which got graduated by CNCF. So after Kubernetes, the second famous cloud native project was Prometheus. And again, as you know, when it comes to cloud, we are inclined towards Python. But when it comes to containers, everyone is inclined towards Golang or Go language. So when you talk about Prometheus is also written in Go language, right? And when you talk about Grafana, now Grafana is again an open source solution which provides you the data analytics capabilities. It can fetch the metrics from different data sources like Prometheus or any other supported data sources. You can visualize the things on your dashboards, and you can create customized, custom dashboard creations. You can do whatever you want to do using Grafana, right? So these two are the deadliest combinations and are the de facto for your Kubernetes monitoring and dashboarding solution. If you go to any organization and you talk about cloud native monitoring and dashboarding solution, you will always see Prometheus and Grafana. That is the reason they are very popular, very, very popular, right? Okay. So now next is demo. Now, when you talk about demo, I'm going to show you a real demo. I will not going to do simple stuff because it's again live. So what we have to do is we have to create servers. So I'm just creating stuff over here. What we have to do is we need to create servers. We need to install Kubernetes on top of that. Then we need to create deployments. Then we need to access those deployments and then config maps, secrets. So I'm just creating these sections, Prometheus and Grafana. So what I'm going to do is, now these are the steps which I have to show you practically, and I'm going to make it real practical. First thing is provisioning. Right? So we are going to provision the servers. So I'm just going to provision the servers. Now again, I can do it in a simple way by going into a AWS console, doing click, 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 and create the things for you. But I'm not doing it in that way. What I'm going to do is I'm going to show you the real power of automation. What I'll do is I'm going to use a tool called Terraform. I'm going to create or provision servers and do all of the prerequisites using Terraform. Once servers are provisioned, so I will be having two servers here. One is master, one is worker. Once this is done, I'm going to go to the second step. Now, second step again will be related to cluster setup. Now, what I'm going to do is I'm going to create or install or initialize my Kubernetes master. So what I'll do is cluster setup. Again, I'm not going to do it with manual things. Again, I'm going to show you one more tool, and that tool is actually Ansible. So you can use Puppet, Chef, or any scripting and all those things. So what I'm going to use is I'm going to use Ansible here. So what I have done, I have written the entire Ansible code, which will going to do an entire Kubernetes setup for you. I'm not going to use any tool which is open source or provided by others. We created our own Ansible playbooks to show you the entire setup. So it will going to create entire Kubernetes for us. And then what I'll do is I'm going to create and show you the manifests, right? So Kubernetes manifests. So let me fill this out so that we can have a clear picture. So what I'll do is we'll understand K8. Kubernetes is also known as K8s. Many. So what we are going to do is I'm going to show you things like deployment, YAML files, services, etc. So we are going to use YAML approach, not the imperative one. Then what we are going to do is we are going to understand another stuff, which is your config maps. Now config maps and secrets can be used in multiple ways. So I'll use one option in config map and one option in secrets. So I'm going to use volumes. So I'm going to show you how to mount your volumes using config map. So it will cover your storage or volume part as well as config map part. So we are going to create config map. So I'm going to deploy one application and I'm going to change that. Probably I'll use index.html, some web application only. So config changes using config maps. This will going to be my other demo. Next one is, again, I'm going to show you something called secrets. Now, secret is to parse confidential data, username, passwords. So I'll show you how to encode things and how to use them. So I'm going to use confidential data, username, passwords, etc. Right? And I'm going to use the power of secrets, but this time I'm going to use environment variables. So here we have used volumes. Here I will show you how to pass this as environment variables. So this is going to be our next part, which is secrets. Secret management. And after that, we are going to use, now we have everything, but we are lacking with monitoring. So what I'm going to do is I'm going to set up the entire Prometheus for you. Prometheus setup. So I'm going to show you the entire Prometheus setup. I have already created all of the YAML files for you so that you can just have a look on them. So it will be for monitoring and alerting. Right? And then we are going to create custom dashboards. I'm going to give you one entire demo for cluster, this custom dashboards also. For that, I will be setting up something called Grafana. So we will be creating dashboards also. And this thing is something which you will going to see in every organization. Right? So if anyone knows this entire stuff, it means this is what any cloud native application will be using. So you will be provisioning the servers, installing the setup, creating your cloud native images and creating YAML files, doing config maps, secrets, monitoring them and doing a dashboard. So this is your entire cloud native platform at a very high level. So this is your entire cloud native stuff which you are going to use. Now I'm going to do all these things step by step. So what I'll do is I have my development server. So this is my development server, right? So what I'll do is I'm going to create one directory. So let me create mkdir where m feb 27, right? Enter. I'm going to go inside it. Here, less -lrt. Now, if you see here, what we have is what I have is I have nothing over here. So what I'll do is I'll go back. I'll go to my GitHub account and I'll going to clone one of the repositories I created specially for this demo. So if you see here, dive into DevOps, right? So what I'll do is I'll clone this, hit clone, enter my credentials. I hope they work. Yes. See here, dive into DevOps. Let me go inside it. Let me clear a screen. ls. If you see here, I already created these things for you. Now, Terraform 01, this is the first step. Let me go inside it and let me show some of these files. Now, Terraform itself is a technology. It's a tool. This tool is getting very famous and it will help you to do provisioning across platforms. Now, like you have CloudFormation or Azure templates, they are specific to a particular platform. But when you talk about Terraform, Terraform can be used across platform to do provisioning and setup, right? So if I come here back to sheet, when you talk about Terraform, now what we do with Terraform actually, we create servers and we do all of the prerequisites on top of those servers using Terraform. So what we do is we are going to use a utility called Terraform. It's a command also. So if you do Terraform help, it will going to do all those things. So what I'm going to do is I'm going to execute a couple of commands like Terraform init. Terraform init means example. I want to create these things on my AWS. So I need to download the plugins for AWS. So init will going to do all those things for me. And then I will going to use something called Terraform validate, which will going to validate whatever codes I have written. Are they are passing the lint or not? Syntax is okay or not? Once done, I will going to use Terraform apply, which will going to take my code and going to execute that in AWS, right? And going to do things for me. Now to do that, there are some of the terminologies which you need to remember. First thing is this files. All these files will be having .tf with it. .tf means Terraform file. So this provider means where I want to get connected. So if you see here, I want to get connected to AWS. Right. Second thing is if you see this variables, this is all variables I am creating so that I can pass those variables. K8s master, K8s worker, and K8s security. These are the files which actually is doing heavy lifting for me. If I do cat to it, this is to create master. See this. This whole code is actually going to create master stuff for me. And here I have used a lot of variables which are provided from this section. Similarly, if I come down and I do ls, if I do cat to worker, this is how my worker server will going to get provisioned. Right? All these customizations. Similarly, if I do cat to my security groups, if I do ls, if I do cat security group, this is how my security group will. Now at this point in time, I have just created a single rule to allow everything, right? But in production, we always create big security group rules. Now, if I clear my screen and I do ls, see here, now what I need to do is Terraform init, enter. So as soon as I do Terraform init, what it will going to do is it will going to download the plugin of AWS, and based upon that, what it will going to do is it will going to authenticate me with my AWS account. Now, again, if you closely see here, what I have done is, if I show you this provider.tf, I haven't mentioned credentials over here because I have set my credentials, because it's not a good practice to give your hard-coded values of credentials here. So what I have done, I have set those credentials, AWS access key and secret key, on my local development server, so that if I commit it on a hit, my credential should not get breached or should not get lost, right, or compromised. So that is the reason I am not giving credentials over here, but it is getting authenticated because credentials are set locally on my system. Okay, let me clear the screen again. ls. Now first thing is done. As soon as I do Terraform init, it is actually going to create this Terraform file, .terraform file for me. Now next thing is validate. If everything is okay, if all syntax are okay, I will be able to see yes, success. Now what I will do is Terraform plan. Now Terraform plan will tell me what all things it is going to create for me. If you see here, you will be able to see some plus sign here. See this, plus. These are plus means these all things are going to get created. If I come here little up, see here, plus create. I'm going to create one instance master. If I come down, I'm going to create one instance called worker. If I come down, I'm going to create one security group also. See this. And that is the reason you are able to see number 3 here. 3 to add. It means it will going to add 3 things in our plan. So Terraform apply. So as soon as I do Terraform apply, it will going to create things for me. Before doing yes, let me go to my AWS console and let me show you if I do a filtering here, and I'll show you there is nothing running apart from my development server. So if I do state, I do instance state as running and instance state as pending, you will be able to see only my development server is running. Apart from that, everything is down. As soon as I hit this yes and enter, you will see the magic of Kubernetes here. Now what Kubernetes will, the magic of Terraform here. Now what Terraform will going to do is, it will going to provision servers for me. So if I wait here for a couple of seconds, I will be able to see things are getting started here. See here, it started provisioning Kubernetes master server for me, right? So this is the automation. Without logging into a AWS console, I'm managed to interact with it and I'm able to create my master server. So let's wait and see. So it will going to create the entire Kubernetes, environment servers for me, master and then worker and whatever prerequisites are required, like their networking and all those stuff. Let's wait for a couple of seconds. So it will going to take 1 or 2 minutes and it will going to provision things for me. By that time, what I will do is, what you can do, you just go here, terraform.io, terraform.io. If you go here, you will be able to see the entire information about Terraform. So you just go to the documentation, right? Go to Terraform CLI or introduction to Terraform probably. You will be able to see all details over here. See here, what is Terraform, how it works and all those stuff. This is very useful and a lot of organizations are using it now, right? Let me come back. See here, master server is done. Now it is creating worker server. If I come back here to my AWS console, if I refresh the screen, see this, worker and master, they are running. And see here, they are getting initialized. It means they just got created a couple of seconds back. Come back. See here, it is saying 3 resources added. See this. My provisioning is done. So I'll come here. See here, my step number 1 is done. So I'll just write done. So my step 1 done. Now step 2 is, I have servers now. I want to install Kubernetes on top of that. Now to install Kubernetes on top of that, either you can do things manually. You can go to kubernetes.io. You can go to this page called kubernetes.io. You go to documentation and here you have cluster setup. So if you go here to kubeATM setup, you will be having all these manual steps, right? Which you have to go through and you have to learn and you have to do. Now what I have done is, referring this, I have created an entire playbook, including all of the prerequisites also, like Docker installation and all. Now what I'll do is, I'll come back. Let me clear a screen. Let me come out of it. ls. See here, cluster setup. Enter. ls. Now we come to the other part. Now other part is Ansible. Again, Ansible is an automation tool. Like Terraform, you have Ansible as an automation tool. What you do is, you write playbooks here, or you can write roles also. Just to make things simple, lot of organizations, they just stick to playbooks. Now you can create roles and you can share it with other teams also. Now, once you create playbooks are nothing. These are the simple YAML files where you will be writing what you want to do. So it's your automation files. Once done, what you have to do is, you just need to use Ansible-playbook command with playbook name. Right? Now, what it will do is, it will going to make a connection with your servers and it will going to do the automation for you. So again, in Ansible, you will be having one automation server, which is making connection to other servers and doing this stuff for you. Right? So what I'm going to do is, I'm going to show you this thing now. Come back. See here, what I did, I created complete cluster setup.yaml. If I do more to it, I have done a lot of stuff over here. See here, step number 1 is to install Docker and Kubernetes packages. So if you see here, I created this entire stuff. This is all YAML automation in Ansible. Come down, see here, these task section, I am creating Docker, installing Docker. Once Docker got installed, I am creating the things for Kubernetes. See here, and we are installing specific 1.19.0 version of Kubernetes and 19.03.11 version of Docker, because this is the second last version. If I come down, once it is done, next part is, in the same playbook, I wrote another play, which is making your or setting up your Kubernetes master server. Once master server is set up, after that, what we are doing is, we are actually attaching a worker to it, right? And once this is done, what we are actually finally doing is, we are configuring our client, our development server, so that from my development server, I can interact with things. right? So what I'm going to do is I'll clear the screen. Let's see here this. Now what I'll do, Ansible playbook name. And here what I need to do is I need to give -ask-pass. What I have done, just to make things simple, I haven't created or generated uh, passwordless authentication between new servers. So what I'll do is it will prompt me to give password so that this server, this Thinknyx dev server, can make a connection with my Kubernetes master and Kubernetes worker server, these servers. Instead of doing it with key-based authentication, I'm doing it with password-based authentication, because Terraform have already created the inventory file, but I haven't kept the password and all those things there because it's again security breach. I'll do this. It will ask me for the password. I'll give the password, which I will not share with you. So I'll just do it. Once password is authenticated, see here, gathering the facts. Now, if you see here, automatically it have connected with these two servers. Now, if I come back, see here, these two servers are, if I go to my console, 3.239.92.134, see here, and then 44, 192, 194, see here. This all happens because my Terraform have set the inventory for my Ansible. So at a very high level, till the time this installation is going on, let me open a paint and tell you. What happens is in Ansible, you will going to have an Ansible controller node. Controller node, you can say this is your master for Ansible. And from this, you can control your entire environment, right? Let's say I have 1, 2, 3, 4, 5, 6, and 7 servers. But I just want to manage these 3 servers using Ansible. Now, what I have to do is I need to create something called Ansible Inventory. Like you have etc hosts file in Linux, similarly, you have etc Ansible hosts file in Ansible. Here, what I will going to do is I'll going to put the entries of this. Entries of these servers. Once I put the entries of these servers, what will happen is it will going to manage, my Ansible will going to manage this server, and this server. Then while writing playbooks, when I'll write playbooks, inside these playbooks, I'll refer to the servers. Now those servers are actually first of all going to check either those servers are present in this inventory or not. If present in this inventory, then only your Ansible will going to authenticate with that server. Otherwise, Ansible will fail and say, I'm unable to find any server. This is how your entire Ansible works, right? So it's at a very high level. So I'll just again close this. New one, click, come back. See here, things are going on. See here, things are going on good. If you closely see here, Docker got installed, Docker got configured, Kubernetes got installed, Kubernetes got master got installed. Yes, so we have things done. So if I come here, let me clear a screen. If I do kubectl get nodes and I'll enter, see here, I'm able to see 2 servers. Now I configured kubectl in my local development area so that I can authenticate with my server. If you closely see here, worker is not in ready state yet. Wait for a couple of seconds. Once networking gets set up, you will be able to see worker also in ready state. Now I can say, let me clear a screen. kubectl get nodes. Now I can say that my Kubernetes setup is ready. So we have a Kubernetes 2-node Kubernetes cluster with 1.19 version of Kubernetes installed on top of that. Now it means if I come back here, so this part is also done. My part number 2 is also done. Now the next part. Next part is creation of your services or Kubernetes platform usage. This is platform creation. Now this is platform usage. Now I want to leverage or use cloud native platform. For that, there are 2 ways. One is command line, one is YAML. If you have YAML, you can do versioning also. And that is why organizations will going to use YAML. If I come back, if I go out and I'll again go out, I'll create mkdir, let's say demo Feb 25 or 27. Right? I go inside it. I'll clear the screen. The one way of creating YAML file is you should have a thorough understanding of API tree for Kubernetes. Example, if you people ask me to create any YAML file, I can create it. What I will going to do is I'm going to do VI, put the things, right? Example, if you ask me to create a deployment file, what I'll do is VI, let's say test dep.yaml, enter, I'll come here and I'll start writing it. Hyphen, 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 API version, apps v1, kind, deployment. So I'm just writing it in a quick way. Metadata, name, let's say Yogesh dep. I'll give labels, I'll give app, Yogesh tab, I'll give spec, I'll give replicas equals 1, selector, match labels, I'll give app, Yogesh tab, and I'm going to give again a template. Inside template, I'm going to have metadata. In metadata, I'm going to give name, let's see, Yogesh pod, because this is a metadata for my Yogesh. Labels, I'm going to put labels as app, Yogesh tab, and I'm going to give spec. Inside spec containers, inside containers name, let's say Yogesh con, and I'm going to give, I think my name spelling was wrong, and I'm going to give image, let's say httpd:/. Now this is the template you have to write. Now you people will be thinking, Yogesh, you have written it in a very quick way. We are not able to understand it. Obviously, because this is first time you are able to see it. How I have developed it, it's purely based upon my experience. And from where that experience came from this entire API system which I showed you. Now, what I have done, actually, I have referred this API system, this API, Kubernetes API tree entirely here. So API, this API version, kind, metadata spec, all these things. Then I went to a spec. Under spec, I used deployment specifications. Here I have used, replicas, selector, and template, and so on and so forth, right? But for anyone who is new to it, I think these things is good. But can't we have something which can generate some skeleton like this, and we just need to do amendments and customization? Probably it will going to solve our purpose. Now, when it comes to your production or quick things, or if you are preparing for your CKA or CKAD or CKS exam, writing these YAML files, it's not going to work. What you have to do is you need to find shortcuts, skeletons. Now, what I'll do is I will not going to save this. And what I'll do is ls, let me clear. See here, there is nothing. I'm going to generate a skeleton like this. What I'll do is kubectl create deployment. I want to create a deployment object. The name of that object will be Thinknyx demo dep. Right? I want to use an image for that. Let's say I'm using an image Yogesh Raheja DevOps in action :v1. Now what I will do is I will going to run it in a dry mode. --dry -run. Till 1.18 version, you just need to give -dry -run. From 1.19 version onwards, even you have to give something called client here. Otherwise, you will be able to see one warning. So what I'll do is I will not give client. I will just show you that warning, right? And after that, I want to generate a YAML for it. And I want to redirect that YAML somewhere. Example, usually we always put a name same. So it will be your Thinknyx demo dep dot YAML or YML, whatever you want to give, right? So what you have to do is you have to give this, put enter. As soon as I do it, it will going to create a skeleton structure for me. Now, this is the information which is actually getting stored in your etcd also. If I do cat to it, see here, the skeleton got created. The skeleton is having some other information also, which is not required. What I do is, let me clear a screen. Again, do ls. Let me do vi here. Now, if you see here, creation time, I haven't created it. Otherwise, it will be a creation time. I just generated it. So you can remove this time. I don't need it. Come down. Strategy by default will be rolling strategy. If you want to do customization, okay. Otherwise, remove it. Why should I need it? Creation time, I don't need it. Resources, I'm not going to put any resource quotas here. Remove it. status, it will automatically get amended once you run this. Do it. If you see here, this is the same file which I created using API knowledge of mine from here, and this is something which I generated also. See this, exactly the same. What I'll do is save this. Let me do a cat again. Enter. Now, if I do kubectl, now get deployment. Now, this is deployment file. See here, there is nothing. If I do get rs, there is nothing. If I do get pods, there is nothing. What I'll do is this YAML will going to create everything for me because this is a deployment YAML. It will going to create rs, and rs will going to create pod. Pod will going to create containers for you. So let me clear a screen. kubectl create -f, and what I'll do is I'll going to create my enter kubectl get deployment kubectl enter. See here, everything is 111. This 111 means number of replicas. If I do get rs, c1. If I do get pods, c1. Now if you closely see the naming convention, this is my deployment name. This deployment have created this replica set, a hash value. This replica set has created this pod. And now this pod is going to be a self-healed pod. Example, let me forcefully delete my pod. kubectl delete pod name, right? And I do enter. Now see here, pod is getting deleted. If we are using Kubernetes, we're going to see the magic of Kubernetes here. See here, 6 seconds back, automatically it got recovered. The name got changed. This is the self-healing capabilities. If you want to scale, no problem. Vi, same file. You have replicas here. Instead of 1, I need 3. It will going to scale these things for you. Enter kubectl apply -f. Usually when you create the things for the first time, we use create, and when you apply changes, you use apply. Otherwise, you can use apply also. Apply will do create also for you. So don't get confused if you see apply there. So what I'll do is enter. See this warning, just ignore. Deployment, this is this got configured. What I'll do is kubectl get pods. See here, 3 pods. If I do kubectl get deployment, you will be able to see thing number got changed to 3. If I do kubectl get rs, enter, see here. This is number of pod. This is number of pod. This is number of container inside a pod. Always remember. Right? Perfect. Now, question is, I created a deployment, but how can I be able to access it from outside? Again, for that, you need to create something called services. I can create services using YAML, by typing one by one line, or again, I can use a magic of Kubernetes. So I'll create kubectl create service. Let me do -help. I will going to create a node port type of a service. Enter. Perfect. So kubectl create service. I want to create a node port type of a service. I need to give a name of a service. So I'll give a name of a service as Thinknyx demo dev svc, and I'll going to use TCP port -TCP. Service port is 80. I'm keeping service port 80, and I'm keeping my container port also 80 because my application works on port number 80. After that, I'll going to give node port, right? I want to access it from, let's say, 30005. When you install Kubernetes from 30,000 till 32,767, these ports will going to get reserved. So I'm going to use this. You can customize them, but I'm using the default one. And then what I need to do is I again need to use -dry -run, and I'll going to use -o YAML, and I'll going to give this redirection this dot. If I clear the screen, now again in your exam, CKA or CKAT, these are very handy. So if I do clear, if I do ls here, see here my file got generated. Now, again, I'll come to paint. I created a deployment. I created a service, right? Now what I want to do is I want to associate them together. Because from outside, I will have to come to a service to access my deployment, because this is the networking component to access applications. Now here you use one more concept, which is known as labels. and selectors. You label a object and you filter that object. So I have already put a label to my deployment. I'm going to use filtering at service level so that this service will get associated to this deployment. This is all customization I will do here. So I do vi, come here. So if you see here, app. Now app is not this. I want label to be this. Similarly, I want selection to be done at this. I don't need status field. I'll remove that. I don't need timestamp creation. Right? If you will not give, if you will not change these things here, the filtering will not happen. And if filtering will not happen, they will not get associated. And if they won't get associated, you will not be able to access your service, your deployment via this service from outside. Come back, save kubectl, create -f, enter. If everything is okay, things will work. Kubectl, now I'll tell you, kubectl get pods, -show labels, enter. labels. See here, app equal to this. Now this is the label associated with my pod, which is running here, right? Now I want to check which service is actually redirecting here. I want to do which selector is actually referring to it. What I will do is kubectl get svc -l. -l means -- selector. And I will give, can you please filter out these things for me? Enter. If I filter it out, see here, I will get this. If this thing is not coming, then you will not be able to see things from outside. In your CKA exam, probably you will get questions like this in troubleshooting sections. This is the skills you have to apply there. Now, if you see here, port 3005. Now, what I will do is I'll try to access my application from here. So I'll go to my worker. I'll copy this, come here, 30005. See this. Hello all, this is version 1 of my testing application. Now this is actually running inside a container. This is the magic. This is the thing which you have to do when it comes to your stuff. Now what I will do is, let me delete everything. Now this is something which is this demo. This is done. Now next is we will come to your config maps and secrets. I'll come back, right? Let me clear a screen. ls, what I'll do is kubectl delete -f dot. Dot means whatever is present, delete everything. So it will going to delete stuff. So if I do kubectl get deployment, you will see things are gone. Now what I will do is, we were getting this page, right? This is a default page. Now without changing the image, I will use config map and I will change this page. For that, I will going to use a power of config maps. But before that, what I need is I need index.html file. So right, this is one of the file I have created and I'll paste it in, let's say, demo, Thinknyx demo tab. Okay, so this was not a directory. That was not a directory, it was a file. So what I'll do is copy this to my current working directory. Okay, so I have to do /ls. Let me clear a screen. So what I did is I copied index.html here. Now what I'm going to do is I'm going to create a config map file. Again, I'm going to use imperative approach here. So kubectl create, right, config map, let's say Thinknyx config map -- so let me, you cannot remember all options, so better you can do a help and get it done. So I'll give Thinknyx config map and I'll give -file -from -file, and I will create it from the file which I have given, which is index.html. And once this is done, -try -run -o YAML, and I'll put it inside this .yaml file. So what I'll do is ls here, or let me clear a screen. Ls here. See here, I generated this file. If I do cat to it, you will be able to see entire detail here. This is how this file got created, which automatically copied this file over here. Right. So let me clear a screen. If I do kubectl get cm, see here there is nothing. Cm means config maps. So what I'll do is I'm going to create these things one by one. So first of all, I'll create config map. Kubectl create -f config map.yml, enter. If I do kubectl get cm now, I will be able to see this config map got created and it's having only one data. Now again, I'll come to paint, right? Because we are extending our solution. We are having a deployment. We are having a service, right? We have associated that together. Now we created a config map. Now what we want to associate or pass this config map to this under the here under the deployment to pods. It means we need to do some changes at deployment levels. So as I told you, I will going to demonstrate volumes, how you can use config maps as volumes here. So what I'll do is I'll come back. I'll open this demo depth YAML again. I'll come to this section, right? Under the specification of pods, there is something called volumes. I am defining volumes here. So I'm going to give a name to it. Let's say I'm giving a name called data wall. And which type of volume I'm using? I'm using config map. Config map, right? Again, all these things you will be able to see from your documentation. If I come here, let me do it in a quick way. See here, if I go to pod template, pod spec, right? If I come little down, see here, I'm having volumes under pod specification. If I click to the volumes, if I come down, you will be having something called config map. So this config map is here. Under this config map, sorry, under this config map, you will be having, see here, item and name. So I'll come here and I'm going to have name. Name is, let's say, name of our config map, which we have given as Thinknyx config map. This is the name of a config map we want to use, and inside that there are items. Items means data values. Inside items, you will be having it as an array. So it will be a key, which is index.html, and you will be having a path, which is also index.html. Yes. If I come here, let me check it. Inside items, it's an array. Array is having key and paths. Key and path. So this is definition. Now I want to use it inside my pod. Again, I'll come to a container section. In container section, you will be having something called volume mounts. I want to mount it. What I want to mount, I want to mount a volume. Which volume? This data wall. Where you want to mount? I want to mount it inside my container at a mount path, which is your var www html. I want to mount it over here because this is where my default page is actually referring to the configuration index.html file. I'll save this, enter cat. If I do this demo dev stuff, see this. So I'll take 10 more minutes because I want to demonstrate everything. So please bear with me. So if you see here, this got created like this. So what I'll do is kubectl create -f Thinknyx demo. If everything is okay, kubectl get deploy. I will be able to see deployment in running state. Get pods, enter, things are running. Let me create a service also. Kubectl create -f Thinknyx dep demo svc, enter. Let me clear a screen. Kubectl get svc, see here, port number 3005, right? But this time lot of things got created. If I come here and I refresh it and I do enter, see here, this time it is having a page 3005. See this. This is not showing you that simple page. Now this is the HTML I created and we have kept it over here. This is how you can pass the configurations inside your pods using Kubernetes without changing or recreating your images. That is something which you will see in every organization. Without config maps, Kubernetes is not a good solution. Come back again, right? Even if I have to show you how I can check it out. kubectl get pods. If I come here, kubectl describe pod name, enter. If I go a little up, this will give you the details about your pod. If you come here, see here, you will be having something called mount. Inside mount, you will be having, see this thing. Something got mounted from data wall. What is data wall? If you come down, see here volume. Data wall is a config map. And which config map? Thinknyx config map. And what is Thinknyx config map? You already know that. Now this is how you mount config map as volumes. This is this section, which is done. Now next section is my secrets. I'll again extend the same example, and we will create some secrets, and we will use them. What I'll do is I'll come back. Let me clear a screen. kubectl get. Okay, so let me do ls. Let me delete my deployment and service that I can show you fresh things. kubectl delete -f svc, and I will not going to delete config map. Now you can do it, and then you can do finally dot and do that. But I'm just keeping my config map as it is. I'm going to create secrets, then deployment, and then services. Let me clear a screen again. Let us create a secret also. So again, kubectl create. Now before creating it, let me tell you why we are using that. If I do kubectl get cn, we are having things. If we do kubectl describe config map and config map name and do enter, you will be able to see your HTML file here. This one, this file here. Now this is not confidential, right? You're able to see whatever you have done. And if you have your username and password like this and you're passing it like this, it is a security compliance issue. And to do this, what we do is we take this information out and we encode this information, right? That is what secret does. So what I'll do is kubectl create secret. I'll do -help. There are 3 types of secrets which you can create. One for registry, one for your TLS, and rest of the things will be generic. So I'm going to create a generic because I'm creating username and password. kubectl create secret. I want to create a generic secret, right? -help here also. So I want to create. So kubectl create secret generic. Let me create Thinknyx sec, which is a name of a secret. After that, I will use a literal values, right? This, let's say user underscore name equal to Yogesh, and hyphen literal hyphen from, let's say user underscore password equal to, let's say Yogesh 111. So I'm just creating these two things which are actually Kubernetes will automatically encode them, right? So what I'll do is -dry -run, which I will show you. -dry -run -o YAML, and I'm going to put it inside Thinknyx secret dot YAML, and clear the screen. ls, see this secret file got created. If I cat this file, see here. Now this is base 64 encoding. Now this time it is not showing you the real things. It is showing you the encoded values. Now what I'll do is kubectl create -f Thinknyx secret.yml, enter. kubectl get secrets, enter. Enter. See here, Thinknyx secret got created. If I describe this, kubectl describe secret name. See here, this time data is not there. But with config map, it was showing. If you want to pass configuration, you use config maps. If you want to pass confidential data, you have to use something called secrets, right? Now what I'll do is, again, I'll go back to our paint, right? Now we also created something called secrets. We want to pass these secrets to our pods. Again, you need to change your deployment files. What I'll do is, I'll come back, vi Thinknyx demo dev .yaml, come here. Last time I used it as environment variables. This time I'm going to use it as, sorry, last time I used it as volume. This time I'm going to use it as environment variables. Again, I'll come back. Come here, come to your pod section. Inside pod, you have pod spec. Under pod specification, you have containers. If you come under containers, you have something called environment from. So I'm going to use this value over here. Come back here. I want to use environments from. Where you want to use it from? Come here. See here. This is an array. Array means we'll be starting from hyphen. Under this, you are having keys, which is your secret reference. Under secret reference, again YAML. So it's a dictionary. Click here. See here name. Copy name. Name is name of your secret, which is Thinknyx. Save this. Cat. Just to show you. See here, a simple YAML file is becoming production-oriented YAML file now. See this. This is how people are actually developing it. See this. I'm having config map. I'm having secret also. So what I'll do is kubectl create -f your deployment. Likewise, I'll going to create SVC also, service also. Enter. Clear the screen. kubectl get deployment. See here, deployment is up. Config map, secret, SVC or service. See here, all things are up and running. What I'll do is, let me show you pods also. See here, go inside any of these pods. kubectl describe pod name, enter. If you go a little up, see here, this time you are having environment variables coming from secrets. See here, environment variables coming from a secret. Which secret? Thinknyx. Now mounts, see here. This data wall is getting mounted here. From where this data wall is coming? Come down from the volumes. Which volume? Thinknyx config map. So it is a part of config maps. Right? So this is something which you are going to see in production every time you are using cloud native stuff or Kubernetes. Right? So this is your secret management. Now next thing is we'll understand Prometheus. Now, Prometheus is not a part of Kubernetes. It's a third-party tool. So what you do is, if you want to explore more about it, go back here. Just go to prometheus.io, right? Prometheus.io will going to give you all the details, right? If you see here, it's approved or graduated Cloud Native Computing Foundation project. So if you want to read about it, go to the documentation and you will be able to see all these things, how it works and all stuff. What I have done is using this documentation and the code they have provided, I made that code simple so that I can demonstrate it live. So what I'll do is I'll going to demonstrate Prometheus live here now. So let me do cd dot. If I go to my repositories back, I have created the entire, like I showed you creation of manifest, I created all these things for Prometheus also. If I do clear here, so I created a couple of other objects like namespace, cluster role, config map, deployment, and secret services. What I will do is let me deploy it directly. kubectl delete, sorry, kubectl create -f dot means everything. Enter. See here, all these YAML files got created. What it have done is kubectl get ns. It created one specific isolated environment for me, which is known as namespace. Under this namespace, it have installed all of the objects related to this particular deployment for me. If I do kubectl get all -n monitoring, see here, under this namespace, all of these things have been created. If you see here, this Prometheus is actually exposed at port number 30,000. So what I'll do is I'll come here. I'll come to my, I'll take any IP, let's say this IP, and 30,000. If everything is okay, I will be able to see the Prometheus dashboard here. See here, this is my Prometheus. Now, after some time, what it will do is it will going to fetch the information from your Kubernetes ecosystem, and it will going to populate the metrics over here and alerts over here. right? You can even create custom metrics and custom alerts. And Prometheus comes with something called PromoQL, which is Prometheus query language. You can use that and you can create your own custom queries. But I will going to just show you the inbuilt queries. See here, this is the main dashboard. If you come to the alert section, you will be having all these alerts. See here, we have one high pod memory. So one pod with high memory is here. If I come to graph, it will show me all these things based upon the metrics. If you come to status, it will tell you all the details. See here, this is the runtime details. These are the command line flags. These are the configurations we have used and so on and so forth. So I'll again come to the graphs. Now these are the inbuilt metrics. See here, these all are the metrics which got inbuilt. Example, I want to see something called running pods, kubelet running pods. Click here, execute, and it will going to show you there are 2 kubelet pods which are running, right? And if you want to see that in graph, click in graphs, you will be able to see here this line and this line. Come down, see here. Similarly, if you come here, now it is showing you just a couple of minutes here because we have just installed it. You come here, come to your, let's say, container or some memory, let's say container memory swap, execute it, come to console, see here, a lot of things are coming over here. If you come to a graph and after some time, you will be able to see a colorful things over here, see here, right? But if I ask a normal guy to come here and check all these things, it will be too complicated, right? For monitoring people or people who are working in the alerting domains or teams, it is okay for them. But when it comes to a normal user like me or you, probably we will find it more useful if we can take this information and create beautiful graphs out of it. This is where your Grafana will come into a picture. Again, now come to Excel sheet. This part is done. I'll come to the last section, which is my Grafana. Right? Again, what you do is come here, go to grafana.com, which will going to give you the information about Grafana. Now, Grafana comes in open source, enterprise, as well as SaaS offerings, right? So you can come to Grafana here, right? And you can read whatever things you want to read. I would suggest you to read about Prometheus here, about Prometheus here and about Grafana. See here, de facto monitoring system for Kubernetes and cloud native. Platform for querying, visualization, and alerting on metrics and logs wherever they live. So Grafana will take the metrics from Prometheus and give you good dashboards. What I will do is, again, I'll come back, clear the screen, ls. I'll go back to the Grafana setup. Again, I have created the deployment for it. See here, config map, deployment, and service. What I'm going to do is kubectl create -f. What it will do is it will going to create everything for me under the same namespace. So if I do kubectl get all -n monitoring and enter, see here under monitoring I have all, see here 30,001 my Grafana dashboard is there. Come back, I'll take the same IP, right? This one. Better I can take the master one so that I can show you what I can show you that it can work on a different server also. If I do 30001 enter, see here, if everything is okay, I will going to get the Grafana. See here, so I will, the by default password is admin, and it will prompt me to change it because this is first time installation. So I'll give it something. Enter. Now by default, you will be able to see there is nothing. Now again, to understand how to create all these things, you need to understand Grafana as a tool also. What I will do is, I will going to show you one of the dashboards which you can create. Now again, I'll go to Grafana dashboard. If you come here, Grafana, here there is something called dashboard. You will be able to get predefined dashboards here. Click here and it will take you to a dashboard page. Come down and you can search out for the dashboards from here. Example, now if you see here, if I search for Kubernetes, right, Kubernetes, here, these are the dashboards which are for Kubernetes. If I come down, see here, there is one dashboard which is using 7.6. This time it have been downloaded. So I think it is better. Click here, come down, and you will be able to see something called dashboard ID 8588. So you just need to copy this ID. Go back to your dashboard, come to this plus point, this box point, sorry, this plus point, and come to this section called import. Click here. You have import Grafana, the dashboards from grafana.com. Copy that ID over here and load it. And what it will do is it will going to take that Grafana dashboard code from grafana.com and it will come here. See here, it is saying which will going to be your data source. Now I want Grafana to take the metrics from your from your Prometheus. So what I'm doing is, well, let me show you it in a simple way so that you can actually understand what we are doing. We were having Kubernetes, right? Kubernetes metrics are being collected by Prometheus. Now we will use Prometheus as a data source and we will give that information to Grafana to create custom dashboards or good dashboards. So what I'm doing is in Grafana, I have to give that you have to take data from Prometheus. Come here, see here, Prometheus, come, automatically Prometheus came. Click, import. And what it will going to do is it will going to import the things here. See here, now dashboards are coming. If I come here, see this nodes, automatically it have fetched Kubernetes master and Kubernetes worker. It will take some time and it will fetch all information. See here, used CPU cores are 1.39. If I come down, see here, this is things related to master. This is things related to your worker when it comes to your CPUs. As time will progress, you will see all this dashboard will be having these graphs. Come down, see here memory usage. Come down, there is no disk usage as of now. Come down, all network usage is here. If you go up, you want to filter out the things, come here. If you do just master, it will just going to show you master things. Again, if you want to check things related to worker things. Again, if you want to do things related to all things. Even you can use PromoQL here to query your custom things and fetch that data which will get displayed over here. Right? So at the end, what you will be having very good dashboards over here. And this is what was the last demo over here.